M into I1. So this I1 can be cancelled. So M is equal to mu naught N1 N2 A by N. This is a very simple way in which you can able to derive the mutual inductance of a pair of coils. Next we will move into the topic of the how exactly you have to keep the primary and secondary so that the EMF induced in the both the coils can be maximum. Suppose when you keep a coil in this manner, I am going to discuss about the three position of the pair of coils. If this is a primary and if this is secondary, and the primary, the coil flux produced in the primary cannot be able to link. Only the few flux can be linking with a few number of turns. So the flux induced in the secondary will not be maximum. Or if you keep that the primary coil and secondary coil along the same line, then the flux of the flux of suppose if this is a north pole, this is south pole, the flux of the primary cannot be able to link the entire length of the secondary. Again, that the amount of induced EMF when you keep both the coils along the same line will not be the maximum. Then what is the way in which you have to keep both the coils so that the flux induced in the secondary coil can be maximum? So it is very simple to understand. You take one cylindrical coil, a cylindrical coil like this. First you wind the number of turns of a primary, then in the alternatively you can wind the secondary. Then when you pass the current, the change in magnetic flux produced in the primary will be fully linking with the entire turns of the secondary. So the flux of the primary will be fully covered by the secondary. So the flux induced in the secondary is very much maximum due to the flux produced in the primary. So this is how you can able to achieve the maximum induced EMF when you wind the two turns alternatively in a single soft iron core. So the question may be asked from this point, from this idea, what are the ways in which the two coils can be placed so that the maximum induced EMF can be induced? Number one, the amount of induced EMF depends on size and shape and the number of turns and the medium of permeability in which both the coils are placed. Second one, and the proximity of the coils. What do you mean by the proximity? The way in which the coils are actually wound. The next we will move on to the methods of producing induced EMF. It's an important 3-mark question. Methods of producing induced EMF. So what is the second law of Faraday's? E is equal to minus d pi by dt, and phi is equal to Ba cos theta. By substituting phi, and E is equal to minus d by and dt and Ba cos theta. If the coil has n number of turns, you can say NBA cos theta. The number of turns, if it is constant, you can take that n out. So what are the variables or letters which are enclosed by the d by dt? Should be understood, they are all changing quantity. So you can either change by the magnetic, you can change either magnetic field or area or angle. This theta is orientation. Orientation means what? The angle between normal drawn to the coil and the magnetic field. So I'm going to write that I'm going to say the three important points. The methods of inducing EMF. 1. By changing the magnetic field. 2. By changing the area. And 3. By changing the orientation of the coil. For each and everything I am going to write the expression now. 1. E is equal to, which one is going to be changed? That keep that quantity under the bracket of the d by dt. E is equal to minus n and A cos theta and dB by and dt. So this is the formula can be written for the method of inducing EMF by changing only the magnetic field. See that I have enclosed the only letter B in d by dt. And second one I'm going to write the expression for the method of inducing the magnetic field by changing the area. So E is equal to minus n say B cos theta and dA by dt. And third one, E is equal to minus n. I'm going to write the expression for how the EMF can be induced by changing the orientation. So n B d by dt and cos theta. So these are the three different formula for making you to understand how the EMF can be induced by changing the magnetic field, by changing the area, by changing the orientation of the coil. Now we are going to see the first method, how the magnetic field can be induced by changing the magnetic field. I think I have already explained the coil and the magnetic field experiment to prove that Lenz's law is working based on the conservation of energy. I hope you remember that. By pushing the magnet towards the downward direction, what is actually done? The magnetic flux enclosed by the coil is increased. By pulling the magnet towards the upward direction, the flux covered by the number of turns by the coil is decreased. So the same experiment can also be given for changing the magnetic field, so that in a closed circuit what is induced? EMF is induced. So either you can move the coil, or you can keeping the magnet, you can move the coil, or keeping the coil as a closed circuit as constant without moving, and you can move the magnet. So either by moving magnet or the coil towards each other, you can be able to produce an induced EMF by changing the magnetic field. Now we are going to see that how EMF can be induced by changing the area of the coil. So now the first point is over. We are going to see the experiment by means of experiment. I am going to prove you how EMF can be induced by changing the area. You take a long wire shaping like a par shape in Tamil, par shape, and keep it horizontally, and whose corners are actually named as P, Q, or S. Take another non-insulated wire having length L, is made to rest on across the arms of P, Q, and RS, and this point of contact can be taken as L1 and M1. Assume that this entire structure is kept horizontally as I show in finger with the help of a stand. When you pass the magnetic field right from top to bottom, and the magnetic field is actually passed through the entire structure in a perpendicular manner to the plane of a single turn of a PQRS coil. So this is the direction of the magnetic field is actually allowed to pass through. So the arrow mark line indicates the direction of the magnetic field. But now you look at the closed circuit. L1, Q, R, M1. M1 indicates a closed circuit. When you now start counting number of lines, will give you the magnetic flux. So 3 is the answer for a magnetic flux. Now what you do is, now just hold this wire named L1 and M1 and pull through a very small distance. And if you just pull that, or I can say, you just pull that wire up to the L2 and M2. The earlier position of L1, M1 was here. Now it is moved by a small distance of dx, and it's moved to L2, M2. Now if you count the number of lines right from L2, Q, R, M2, the number of lines is increased from 3 to 4. So by moving the line, by moving the wire L1, M1 from its own position from L1 to M2 to L2 to M2, what happens? The number of lines, number of magnetic lines of forces covered is increased. So as per the electromagnetic laws of induction, whenever there is a change in magnetic flux in a given in a closed circuit, EMF is induced. Now the magnetic flux increased from 3 to 4. So automatically the EMF is induced, and due to that current will be flowing from P to Q, Q to R. So now how I am going to modify this formula? You can consider that L2, L1, M1, M2 as a small rectangle. So you know the area of the rectangle is called the multiplication of the length and breadth. So small increasing in area of this small segment, and L into, say that L is the length of the wire, L is the length of the wire, L into and dx. So I am going to replace this dA as L into and dx. And what is called dx by dt? Dx is the displacement in a given time t. This gives you the velocity. How many number of turns are there? Only one turn of a path shape is given. So it becomes 1. And theta is the angle between the area of the coil, normal drawn to the area of the coil, and the magnetic field. So magnetic field is moving from top to bottom, and area drawn to the coil is along the same direction. The theta will become 0, cos 0 becomes 1. So it becomes BLV. So we can write E is equal to minus BLV. So EMF induced by changing the area of the coil can be derived as E is equal to minus BLV. So based on this expression, we can get one either 3 mark questions or 5 mark questions.